Let's take a look at 1.4 transformations. So first we're going to talk about vertical and horizontal shifts. So anytime you are shifting vertically, you're going to add a constant to the whole function. And so if you add a constant to the function, you go upwards. If you subtract, you're going to go down with your graph. A horizontal shift, you are adding or subtracting from the x value within the function, the input. And so in this case, if you subtract your constant, you are actually shifting to the right. And if you add, you're shifting to the left. That might sound counterintuitive, but that is how it works, because when you plug it in, it's going to go the opposite direction of what you were anticipating for the most part. Most people think that, oh, we're subtracting, we're going to go to the left, but you're not. You're going to the right. All right, so let's take a look at that. So for example 1, we're going to use the graph of f of x equals x cubed. And so what that looks like is we know that we have 0, 0, and you can make a table of values if you want to create that parent function. That's what this is called, the parent function. And so your x values and your y values. And so if we plug in 0, we get 0. If you plug in 1, you get 1. If you plug in 2, you get 8. If we plug in -1, we get -1. If we plug in -2, we get -8. So let's try those points and see what that looks like as we plot our points. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. There we go. So it's going to generally look like this. Okay, and so then we're going to take the first one, and that is x cubed plus 5. So that is a vertical shift upward. So we're going to take each of these points and move them up 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now the other ones are going to be hard to move. So I'm just going to do this because they go off of our grid. All right, so there is the vertical shift. Oops, sorry about that. There's the vertical shift of 5, up 5. All right, and then for the next one, we're going to the right 3, and up 2. So we're going to go to the right 3, 1, 2, 3, and up 2. And then we're going to do this point right here. We're going to go to the right 3, 1, 2, 3, and up 2. And then we'll do our -1, -1. So 1, 2, 3, up 2. And then let's do our 2, 8. So right 1, 2, 3, up 2. Didn't mean to actually touch the screen there. There we go. And then we'll do our -2, -8. So 1, 2, 3, up 2. There we go. And so it's going to look something like that. All right, so number 2, we're going to take a look at just describing some shifts in the graph. So for A, we have x plus 1. Well, our original function is f of x equals x cubed plus x. So we're looking at, okay, how is this changing? Well, if we look inside our parentheses here, we have x plus 1, and then we have x. So this is actually, well, yeah, we'll do that. This is g of x is the same thing as f of x plus 1. So everywhere you see an x, they plugged in x plus 1. So that is a shift to the left because we are adding to the x value, the input, 1 unit. All right, in B, let's see, we're plugging in x minus 4, but then over here, it's not an x minus 4. And so that one is actually not a shift, but I think that might be a typo. So you know what? Let's just go ahead and fix that. Let's go ahead and make that minus, okay? Because that's what it was supposed to be anyway. And it might be corrected on your document. All right, so h of x is the same thing as f of x minus 4. And so that would be a shift to the right 4 units because we're subtracting. Okay, let's take a look at number 3. Each graph is a transformation of the graph of f of x equals x squared, so that's a parabola. So we're going to write the equation, and these are a little fuzzy, but we'll zoom in here and hopefully we can read that a little bit. So we have our regular function starts at 0, 0 and comes here. Oops, wrong one. And so it would look like this. So this is really just a shift up. So we have shifted up, and it went up 4 units. Okay, so that one was just a vertical shift. And then B, again, our parent function is this. There's our x squared, f of x equals x squared. So we went down 1 and to the right 2. So down 1 and, I'm sorry, to the left 2. So shift down 1 unit and left 2 units. Okay, so now we're going to take a look at some reflections. When you make the entire function negative, so you put in the same input, but your outputs all become negative, that is a reflection over the x-axis. But then if you are inputting the negative values and you get the same thing, you get the same output, that is reflecting over the y-axis. All right. So if our parent function is f of x equals x squared, then we know, okay, so if we have x and x squared, which is really, well, I'm going to put f of x there, which is the same thing as y. So if we plug in, let's say -2, we get 4. Plug in -1, we get 1. Plug in 0, we get 0. Plug in 1, we get 1. Plug in 2, we get 4. All right, so neither of these are reflections. Not sure why. Oh, no, they are reflections. Sorry about that. So normally, remember that our parent function would be going up like this, just like the last problem where we had the parabolas. It would be going up like this, right? So we have a reflection. So we're reflecting over the, we're reflecting over the x-axis because we flipped it upside down. And so that means that the whole thing is negative. So actually we'll call this g of x. Yeah, because it says g right there. So g of x is equal to, let's see, negative x squared, because we reflected over the x-axis, so the whole function is negative. And then we're shifting up, so we're going to add 2, right? And then you can see, well, if we plug in x and g of x, you can check your answer by looking at some values. So if I plug in 0, I should end up with 2, and I did. If I plug in 1, I should end up with -1 plus 2 is 1, and I did. And so you can plug in some points to check that. All right, so now we're going to take a look at h of x. So again, we have reflected over the x-axis, so it's negative x squared. And then we have shifted to the right 3 units. So we need to, in this x value, put our x minus 3 because we're shifting to the right, okay? And then again, you can check your answer by plugging in some points. So we'll plug in some values. Let's say we plug in 3. Plug in 3. 3 minus 3 is 0. 0 squared is 0. And we get 3, 0, which is right there. Let's plug in, let's say 2. 2 minus 3 is negative 1. Negative 1 squared is 1, but then it's going to be negative again, so negative 1. We can plug in, let's say 1. 1 minus 3 is negative 2. Square it, we get positive 4, but then we have the negative out front, so it's negative 4, and that is also on our graph. Okay. So for example 5, we have x cubed plus 3, and we're describing the reflections in the graph of f generated by the following functions. So for a, we have negative x cubed plus 3. So notice that that 3 did not change signs. So we did not multiply the entire function by negative 3 or negative 1, because if we did that, negative f of x would be negative x cubed plus 3, and then when you distribute that negative, you get negative x cubed minus 3. So that one is b, right? And when you multiply the entire function by a negative, remember up here that was your reflection over the x-axis, right? So this one is reflected over the x-axis. And then, oh no, that was the other one, sorry. That's this one, reflected over the x-axis. Put it in the wrong spot. All right, so then for a, if we plug in negative x, that's going to give us, it's going to give us negative x cubed plus 3, and negative x cubed is negative x cubed without the parentheses. So this one is a reflection over the y-axis. So non-rigid transformations, we have vertical distortions, and that's when you're going to multiply your function by some constant. And so if that constant is greater than 1, it's going to be a vertical stretching. And if it is between 0 and 1, it's going to be a shrink. And then we have horizontal distortions, where you're multiplying the x value, the input value, by some constant. And if it's between 0 and 1, that's going to be a stretch. But if it's greater than 1, this time it's going to be a shrink. So depending on whether it's vertical or horizontal, that changes whether it's a stretch or a shrink with the number. So for number 6, let's take a look at some graphs. So we've got h of x equals 3 times the absolute value of x. And then we have g of x equals the absolute value of, that should say 3x. So let's fix that. That should say 3x inside those absolute value bars, with the graph of f of x equals absolute value of x. All right, so we'll start with that parent function. Absolute value, remember, you're just taking the input and making it positive if it was not already positive. So if I plug in 0, I get 0. If I plug in 1, I get 1. 2 is 2. 3 is 3. Negative 1 is positive 1. Negative 2 is positive 2. Negative 3 is positive 3. And so our parent function looks like that. You can see my lines aren't perfectly straight, but that's okay. All right, so let's take a look at this function where we are vertically stretching because it is greater than 1 and we're multiplying the function. So it's vertical. So this is a vertical stretch. So let's see what that looks like. So we could say, okay, x, h of x if you want your table of values. So we could plug in negative 2. And that means we have 3 times the absolute value of negative 2, which is 6. Negative 1 would be 3 times the absolute value of negative 1, which is 3. 0, 3 times the absolute value of 0 would just be 0. Plug in 1, 3 times the absolute value of 1 is 3. Plug in 2, 3 times the absolute value of 2 is 6. All right. So then we're going to plug those points in. We have 1, 3, negative 1, 3, 2, 6. And so you can see, now this is not a parabola, so it does come to a point at the bottom. It's not a curve. So you can see that it has been vertically stretched. All right, and then for g of x, this is a horizontal shrink. All right, and so we are going to create our table of values. So we could do negative 2, and then 3 times negative 2 is negative 6. Absolute value of that is positive 6. And then plug in negative 1. And negative 1 times 3 is negative 3. Absolute value of that is 3. 0, plug it in, you get 0. 1, you get 3. And 2, we get 6. So you can see we get the same exact thing. So a horizontal shrink is the same thing as a vertical stretch sometimes. So they can look the same. They're just written differently. Okay, so let's take a look at number 7, and we're going to describe what that graph would look like. So for g of x, that's basically saying we're multiplying f of x by 3, right? Because if you take 3 and distribute that in to the f function, you get 3x squared, right? And so this would be a vertical stretch, oops, by a factor of 3. All right, and then let's take a look at this one. So we have h of x, and our 1 didn't change, but our 9 are in front of the x, that did change. So we actually have 1 minus 3 times the x value, and that gives us 1 minus 9x squared. So we have, it's f of 3 times x. So this is a horizontal shrink, remember, because it's larger than 1 by a factor of 3. Oops. All right, so if you need to refer back to this set of notes up here to remember, is it shrinking, stretching, if you don't have a graph in front of you to be able to see that. But remember that if you're multiplying the function value, the output, that's vertical. If you're multiplying the input, the x value, that is horizontal.